question, we are told that there is a modelling, so the javelin is thrown and then the front tip of the javelin is kind of tracked through the air and it forms this quadratic equation, so this one here. So we know that we're going to be using our GDC and we're going to be doing a lot of modelling on it. So the first thing to do is to type in the equation of the quadratic curve that was given to us. So it's negative 3.6 x squared. So we replace the t with the x, and then we're going to add on to that 10.8 x plus 1.8. And from that, I can see what my graph looks like. Now, at the moment, it's obviously not zoomed in wonderfully, so I don't really need the negative because they obviously start throwing the javelin here, and it looks like we can get rid of some of the y as well. So I'm just going to move this one to -1 because it's nice to have the axis shown, and if you put 0, then it disappears. And then for the y-axis, I'm going to change this to -10, and let's just go up to 40. And hopefully this means we can see it a little bit clearer there. So the first question is to write down the front tip of the height of the javelin at the time that it's thrown. So that's asking me for this marker here, which is the y-axis intercept. So I'm going to go to trace, find value, and I want to know when x equals 0. And when x equals 0, my y coordinate is 1.8 meters. So it's 1.8 meters, the top of the tip, as it's thrown. And then for the second part of the question, so for part B, find the value of t when it reaches the maximum height. So I'm going to be using my maximum point. I'm going across and finding where that maximum value is equal to. And we can see there, and it asks for the time. So it's only the x coordinate I need. And it happens at 1.50 when rounded to 3 significant figures, seconds. And we should always use our units there as well. And then part C, find the value of t when the front tip hits the ground. So this is where the graph goes back across the x-axis. So it's the 0 that I'm looking for. And it's right down here. And I can find that, and I can see that the time there, don't forget to change it to t because it's not x or y, is 3.16 seconds to 3 significant figures. So that's just saying where did it land into the ground. So you can see there it started, it flew through the air, and then it landed on the ground.